Welcome back again to this edition of the tutorial. Today we are continuing our analysis on quadratic inequalities, but at this time I call it part 2. Yesterday we did the part 1, which was on the section of 3, 5. Very good. Here's the question that says that find the set of values of p for which the least value of f of x equal to s squared plus 3p x plus p is greater than 0 for all values of x. What's the meaning of this phraseology? It is not a big deal at all. Let's start it. Solution. F of x is giving us s squared plus 3px plus p, which is in the form a s squared plus b x plus c. Very good. From this expression, if you compare the coefficients on both sides, you can see that the a equal 1. You can also see that b equal 3p. And we observe that c equal p. The question is that what is the least value of f of x? In our previous tutorial on quadratic equations, we derived many formulas, and it was an extensive and a very beautiful and very celebrating topic that we dwelt upon. But in the course of those studies, we came to a point and found that f of x minimum is always equals to 4ac minus b squared over 4a. So, in that case, we can say that where a equals to 1, b equals to 3p, c equals to p, this one becomes 4 multiplied to 1. C multiplied to c is p minus b squared is 3p squared all over 4a. A is 1. Then we have this one again equals to 4p minus 9p squared over a is equal to 1. 4. This is the least value of the above given quadratic equation. That is the least value. This is f of x minimum. And f of x minimum is called the least value. And we also have terminology-wise, the greatest value would be f of x maximum. So the least value of f of x is the f minimum, and the f minimum is 4ac minus b squared over 4a, which yields the right hand side to be this. So in the question, when it says that find a set of values of p for which the least value, which is this one, the least value of f of x, which is this one, is greater than 0 for all values of x. Then for f of x to be greater than 0, then it becomes f of x minimum, or the least value of f of x greater than 0, then f of x minimum is greater than 0, in which case it becomes 4p minus 9p squared over 4 is greater than 0. Good, greater than 0. If we multiply through by, or if we multiply through by 4, it will yield 4p minus 9p squared is greater than 0. Now, if we are going to continue the analysis at this session, then we'll pick up this one and come to this session. So it becomes, we will factorize the p outside. Before we do that, I believe that there's a space down there that we can continue. Picking up this equation and factorize the p outside, we will have p 4 minus 9p greater than 0. Good. Then from here we can say that p is greater than 0 and minus 9p, yeah, you can see it. And minus 9p, which is this one, sorry, 4 minus 9p. 4 minus 9p is also greater than 0. Now, to do very good neat work, we are doing neat work, without causing any algebraic mishaps. Just do it simple algebraic calculations. So if we are going to factorize p 4 minus p outside, you have p equals 0 and 4 minus 9p equals 0, which means p equals 0 and 4p, 4 minus 4 equals 9p, or 4p equal 4 over 9. This one and this one is what we need. And then we'll use, we are going to use, we are going to continue the algebra. So at the meantime, we can see that it is a graph where the curve will pass through the point 0, p equals to 0, and p equals to 4 over 9. Now, let's come back to this inequality again. We now know the points where the curve will cross. Let's come back to this inequality again. Here, we will have, or this inequality, this one. Here, we will have minus 9p squared plus 4, or we will put we will shift the 4p to the other side. So it becomes minus 9p squared is greater than minus 4p. Or we can still maintain it. If we maintain it, it will still be, let's try to maintain it by multiplying both sides by -1. So if we multiply both sides by -1, we have 9p squared minus 4p. As soon as we multiply both sides by -1, this sign will change and it becomes this one. And we will have, if we are trying to factorize p outside, which we have already done, but we are redoing it again. So we will have here p 9 minus 4 is less than 0, where p, the factors are p equal to 0 and p equals to 4/9. That we have already found. Assuming that this one is equals to f of p, then it will mean that f of p is less than 0. But from the previous analysis, we say that when a function, let's say f of x or f of p or whatever, is less than 0, then it will be that section of the curve below the x-axis whose x values we are going to consider. So, assuming, let me take this section. Oh, is there any section there? Oh. Yeah, there's a space there. Let's use, assuming this is there, a graph. And this is f of p. And this is p. So, the graph will look like this. And from here going is what we have. P is less than 0. And from here going is what we have. P, we have P is greater than 4/9. Very good. Let me see whether you can see. Yeah, you can see it right. This is it. So, take your time to copy it and we'll continue. Take your time to copy everything. We are not fully done. But even after you have copied everything, we'll take this session off. We'll try to redraw the graph again and explain, we will do further explanation to conclude. Take your time. Welcome back again. Yeah, we are taking our time to redraw the graph. We know that the values of p, where the curve will cross the p-axis, is p equal to 0. And the other one was p equal, where is it? 4/9. Good. This should be the graph. And the inequality this is the f of p axis. This is the p axis. So the graph will look like but remember, we found out that f of p was less than 0. Because at some point before, f of x was greater than 0, and then we multiplied both sides by -1, and then the sign changed and became f of x is less than 0. When f of x is less than 0, then the x values that are below the x-axis, they will be the correct inequality. So here and here, the x values within this region. So when here is equal 0, and when here equal 4/9, then the inequality will be 0 is less than p is less than 4/9. Let me see my screen. Yeah, you can see correct. So because f of x is less than, because f of p is less than 0, assuming f of p is greater than 0, then the inequality f of p here is 0, here is 4/9, here is 0, then it will go this way. This is valid when f of p is greater than 0. But, however, when f of p is less than 0, then it will be this region. Yeah. So, because we are now considering, we have now found that f of p, in fact, as we multiplied from the previous session, if you go through your notes from the previous session, because the coefficient of p squared was negative, we multiplied both sides by -1, and as soon as we multiply both sides by -1, the sign changed from greater than to less than, which is f of p is less than 0. Then in that case, this should be the range of values of p where the inequality, the requested inequality, is valid. Now let me clean this one and write down some things that are very important. Now, we are saying that hence the set of values of x for which the least value of f of x is greater than 0 is when 0 is less than p is less than 4/9. This is the range. Good. This is the requested range. within these values, within the range of values of P, then the least value of f of x will be greater than 0 within these values of P. Then we are done with that one. And then we move to another question. But in the meantime, you take your time, to copy from where we started. We started from this point, and then we have concluded at this point. Take your time to copy it, and then we will take the next question. Now, welcome back. This is also another question that says that the equation kx squared minus 2kx plus 3 equals 0, where k is a constant, has no roots. Prove that k satisfies the inequality 0 is less or equal to k less than 3. This is not a big deal. A quadratic equation. Okay, let us start by this way. Solution. This is k f squared minus 2kx plus 3, very much identical to ax squared plus bx plus c equals 0, which indicates that a is equals k. A is equal k. B is equal minus 2k. And C is equal 3. If you remember when we did quadratic equations, and we also did the theory of discriminants, and we came to many conclusions, of which one of the conclusions is that any given quadratic equation in the form of ax squared plus bs plus c, f of x equals to ax squared plus bs plus c, ax squared plus bs plus c, when f of x equals to 0, then that quadratic equation will not have any roots if and only if, or a quadratic equation will never have roots if and only if b squared is less than 4ac. What am I talking about? Put it down. Any given quadratic equation has no real root when b squared is less or equal to 4ac. If you have any given quadratic equation and you find out that b squared is less than 4ac, it indicates that that quadratic equation has no roots. We will use the same idea or the same principle to answer this question. So, taking this, very useful information. What is b? B is minus 2k, so b squared will be 4k squared. Is that correct? Yes, that's correct. And what is a? What is 4ac? 4ac and 4ac equal. What is a? A is equal to k. 4k, and what is c? So it is 4 times k times c is 3. So 4ac equal 12k. Now, having known that 4k squared is equal to b squared, we put it here. Having known that 4ac equal to 12k, we put it here. So let's continue. If we continue, I'll call this one equation tau. Putting these values inside equation tau, we will have 4k squared is less or equal to 12k. In which case, we have 4k squared minus 12k is less or equal to 0. Factorize 4k outside, we have 4k minus 3 is less or equal to 0. In that case, we are going to, if we divide through by 4, we will be left up with k. K is minus 3k is less or equal to 0. In which case, the factors of k at this time will be k equals 0 and there's no k here, sorry. Yeah, k equals 0 and k minus 3 equals 0, which indicate that k equals 3. This is where the curve will pass through the k-axis. Will pass through the k-axis. Okay. We are going to make good use of this inequality. Assuming, okay, 4k squared minus 12k is less or equal 0. Assuming this one equal f of k, then it would imply that f of k is less or equal 0. Good. F of k is less or equal 0. Then remember that we are trying to sketch the curve. And when trying to sketch the curve, we know that a function of f of k less than 0, that graph possibly will be like this. And it will be this region that we are going to consider, this region. Good. I would like you to take your time to copy it, and then we are going to clean up this section, and then we will draw a proper curve. So take your time, copy everything as you see on the board, and then we'll come back again. We'll pick it up from here to draw a possible curve to see the inequalities that the question is asking for. Would you please kindly take your time to copy everything? And then welcome back. Picking up from where we left. So the graph of this quadratic equation will be where this is f of k and this is k-axis. This is the origin. So the curve passes through the origin. and comes here. Because f of k is less than 0, you can see that I left space here to make it more clearer to you. F of s is less than k. It is this portion of the curve we are considering, this portion, and the values of x within this region. The values of x within this region is s equals 0, which is here, and x equals 3. So within this region, the values of k, within this region, the values of k rather, sorry, that I said the values of x, we've been always working with x, and I mean, once we change to, to any other thing, we have to really be concentrated, to be more proactive. You see, the values of k within this region is what we are looking for. So k here will be 0, less than, and here will be 3, this point. So we can say that yeah, this is it. That's it. Therefore, 0 is less or equal to k, less than 3, satisfy the satisfy the equation, satisfy the quadratic equation which is this one, or satisfy the quadratic equation ks squared minus 2x minus 2kx plus 3 equals 0. Can you see it? Yeah, you can see it. Minus 2kx plus 3 equals 0, which is correct. I mean, we'll have no root. No roots within the domain or the range of 0, k, and 3. Done. Can you see it? Yeah, you can see it on your, yeah, then we are done with that question. Take your time to copy it, and then we'll take one more question, probably the last question for the day. Welcome back again. This is another question. It says that given that s is not equal to 3, find the values of x for which 5 over x minus 3 is less than 2. Let's bang it down. Solution. Five over x minus 3. We'll apply the previous analysis that we did on last tutorial. This will be, we can write it like this. We can also write this one like 2. we are going to multiply both sides by x minus 3 square x minus 3 square. So we have 5. Maybe I think at this time you are mature. That I mean, you can know that this using indices. This one becomes 5 multiplied to x minus 3, s minus 3. I know that you should know. But if you don't know, let me take the time to do systematic work. So it becomes x minus 3. I mean, nothing should be taken for granted. Let's say it. X minus 3. We have x minus 3. X minus 3, which is s minus 3 squared. This one will cancel this one. And we have 2x minus 3 squared. And we'll be left up with 5x minus 3 less than 2x minus 3 squared. Good. And then the board is clear. We have here 5x, 5 multiplied to x, we have 5x minus 15 is less than 2. We have, expanding this one, we have s squared minus 6x plus 9. Good. Is there any space over there still? Yeah. We have 5x minus 15 is less than 2s squared minus 12x plus 18. Good. Let's continue from here. So we have 5x, and then we bring then minus 12x from that side to this side. We have, it becomes plus 12x, and then we have less than 12s squared plus 18, which is there, this 18, which is that one, and we bring the 15 to this side to become plus 15. So we have 5x plus 12x, we have 17x less than 12s squared plus 33. We will bring this one here, it becomes minus 12s squared plus 17 stays there, 17x minus 33 is less than 0. Good. Assuming this is all, we can multiply both sides by -1 to have this one positive. So if we multiply both sides by -1, we have 12s squared minus 17x plus 33. But because we have multiplied both sides by -1, this sign will change. It becomes this way, which indicates that when this is f of x, then this f of x then f of x is greater than 0. Where f of x is greater than 0, I mean, we'll pick up the s values. The x values, the upper part of the curve, the s values that correspond to correspond to the graph. But I will still explain it. So take your time up to this point. Then, I mean, before we continue, I would like that you take your time to copy everything from here up to here, and pause the video, and I will clean the board, and we will take this section off, and we'll continue from here. I think there was a slight writing mistake over there. This one is not 12. This one is not 12. It's not 12. Why? Because from here, we multiply both sides by x minus 3 raised to the power 2, and we came up with this 5x minus 3, and the other side 2s minus 3 squared. And this one becomes 2 here, s squared minus 6x plus 9. And this one will become 2s squared minus 6x minus 12x plus 18. Yeah, so this one was not 12x, and this one, this is 5x minus 15. In that case, we are bringing everything to this side, so it becomes minus 2s squared, which is this one. It has come to this side, plus 5x is already there, so a minus 12x will come to this side to become positive 12x, and then we have 15x, which is already there, and then we'll bring the 18 plus 18 to this side. It will be minus 18. Then we'll be left up with 0. So we have minus 2s squared plus 17x minus 33 is less than 0. Now, we are going to multiply both sides by, negative 1. So if we multiply both sides by negative 1, we have 2s. We have 2s squared minus 17x plus 33. And because we have multiplied both sides by negative 1, this sign will change, and it will be this. And assuming this one is f of x, then this will be, the pen, let me change it. This will be f of x greater than 0. Can you see it? No, the color is not good. I'll change it for different color. I'll use this one. Then f of x is greater than 0, which is very important to us. Very good. I think copy everything up to this point, and then I'll pick it up from here. Yeah. Continue from there. This is the quadratic equation. We know that 2x squared minus 17x plus 33 is greater than 0. Very good. If we multiply the coefficient, of x squared to the constant, we have 66. But remember, 66 is also not different from minus 11 times minus 6. If we add minus 11 to minus 6, we'll have minus 17. This indicates that minus 11 and 6 are very good constants, very good factors that we can use it for this one. So this equation, as you see there, the 2x squared minus 17x plus 33 is very much identical to 2x squared minus 6x minus 11x plus 33. Good. Factorize 2x outside. We have 2x and then x minus 3. The same minus 3, we'll write it here, x minus 3. The same x minus 3, we'll write it here. And then we can see that if we multiply here by minus 11, we can have minus 11x, which is this one. Minus 11 multiplied to 3, we have plus 33. That indicates that, it's correct. So it implies we are trying to factorize the x minus 3 outside. We have 2x minus 11. Then we have x minus 3. Good. This is equals to 2x squared minus 17x plus 33. Very good. But this one is equals to f of x. Now, this one is equals to f of x, by the way. Good. So the factors, assuming on the x-axis, f of x will be equal to 0. On the x-axis, in that case, we have 0 is equal to x minus 11, x minus 3. That will be on the x-axis. On the x-axis, where the curve will cross the x-axis, y will be equal to 0, or f of x will be equal to 0. In that case, when f of x equals to 0 on the x-axis, then 2x minus 11 equals 0, which indicates that x equals 11 over 2. Also, x and x minus 3 equals 0, which indicates x equals 3. Which indicates the curve will cross the x-axis at 11 over 2 and s equals 3. In that case, if we are drawing the curve, sketching the curve, we'll have something like this. This is f of x. And this is x. Good. S equals to 3 and s equals to 11 over 2. So the curve will be something like this. Here will be the plus 33. 33. And here will be x equals to 3. And here will be x equals to 11 over 2. Now, remember, where f of x, where did we find it? Really? We said that f of x, where was it? I think I've cleaned it. You see, I don't have any written thing with me. So, I mean, I don't have any written thing with me. Yeah, but I think that we said that f of x is greater than 0. F of x is greater than 0. F of x is greater than 0 will be this portion. That part of the curve above the x-axis. So, it will be this section. F of x greater than 0 will be this one. But remember, we said that f of x less than 0 will be this section. This section is f of x less than 0. And this section upward is f of x greater than 0. So, this section we are considering at this time. And we are interested in the x values. From this section going, the x value says that x is less than 3. And from this section going, x value says that x is greater than 11 over 2. Can you see it? Yeah, probably this one wasn't. Yeah. So, this is the inequality. So, therefore, the requested inequality is x when x is less than 3 and when x is greater than 11 over 2. Yeah, you can see it on the screen. Let me see. Yeah. Then I think as you can see that there is a background noise over there. I mean, a guy is making a noise over there. We'll bring the tutorial to close, and we'll come back again next time. So at this time, I'll pray for you. Now the Lord Almighty God keep you. The Lord Almighty God make his face shine upon you and lift up his countenance upon you and give you peace. Shalom, shalom. Amen.